All right, welcome back everyone. Let's go through the solutions to the now you try problems where we are solving rational equations symbolically. The first we're looking at is x over x minus 5 equals 2, and we'll go ahead and multiply both sides by x minus 5 so that we can clear out the x minus 5 in the denominator. When we do this, on the left side, the x minus 5s will cancel and we'll be left with just an x. On the right side, we'll distribute the 2 across and get 2x minus 10. We'll go ahead and subtract the 2x from both sides. And this will give us that negative x equals negative 10. Divide by negative 1 on both sides, and we will get that x equals 10. We want to double check that this actually works in the original equation. And here, the x minus 5 cannot be 0, so we couldn't plug in a 5 for x. But a 10 is going to work just fine. So this is good, and we can say that the solution set is the set containing just the number 10. That's it for the first one. Let's move on to the second, part B, where we have t plus 9 over t squared plus 15t plus 54 equals 0. What we want to do is go ahead and start by factoring that left side. So we're going to have t plus 6 and t plus 9 here, where we're looking at that 54, and we're trying to find two numbers 6 and 9 add up to the 15 in the middle, right? And this equals 0. So we can multiply both sides by the t plus 6, t plus 9. I'll move this out of the way here. Same thing to the right side, t plus 6 times t plus 9. And what we'll get is t plus 9 equals 0. We'll subtract the 9 from both sides, and we will get that t equals negative 9. Now I'm going to jump to the answer real quick, and then I'll go back and explain. The solution set is empty. It's just there is nothing inside of that solution set. And that is because negative 9 is not actually a solution. So this is the first example we've seen where we run into this. I'm going to look back at that previous line and see if we plug in a negative 9 right there, we would get undefined on the left. So let's go ahead and do that check just to really emphasize what's going on here. If I plug in a negative 9 into that original equation, negative 9 plus 9 on top over negative 9 squared plus 15 times negative 9 plus 54. So I'm doing this in the not factored form, just the original, because we want to, it's always nice to check in the original form just in case we made a mistake along the way somewhere. And then this all equals 0, and that's really what we're asking. Does this equal 0? Are we going to get a true statement when we plug in negative 9? So when I do this, I'll get a 0 on top. Minus 9 plus 9 is 0. On the bottom, we'll have 81 minus 9 times 15. Let's just do this. So 9 times 15. This equals 90 plus 45. So 90 plus 45. 9 times 10 is 90. 9 times 5 is 45. And this is 135. This is how we would do this in our brains. So the multiplication that you might have grown up with 15 times 9, and then do the carry the 1 thing, that is not fun in your heads. This is much more doable. And if I could change the world, that would be one change I would make, is we would do all of our multiplication that way. So we'll put in the minus 135, bring down the plus 54 here. We're still asking, is this all going to equal 0? And if we're not careful, we would get 0 equals 0 here, right? If we divided that 0 out. But we need to be careful because, oops. Sorry, trying to make a little room here while was talking and I messed it all up. But because if we add up these denominators, 81 minus 135 plus 54, let's do the 81 plus 54. There's a couple different ways of doing this. But let me show you another way of doing this. So 80 and 50 right here, 8 plus 5 is 13, so that's 130. And then 1 plus 4 is 5. So this is 135. So 81 plus 54 is 135. And then we bring down the minus 135. If we ask if this equals 0, we have 0 over 0 equals 0. And that's not true. This is undefined. And so undefined does not equal 0. It's not the same thing. We cannot divide by 0 even if we start with 0. So once again, and to simplify this, we just see right here and right here that in the original equation, t cannot equal -6 or -9. We got a -9. That's not actually going to work. So there are no solutions here. All right, let's go ahead and move on to part C down in the bottom left, where we have 1 over y plus 2 plus 2 over y squared plus 2y equals 1/5. We will begin this problem by factoring wherever we can. We have 1 over y plus 2, nothing factors there, plus 2 over y squared plus 2y. Here I can factor out a y. I'll be left with y plus 2 after pulling that out. And we'll set this equal to 1/5, or rather bring down the equals 1/5. So our common denominator that we want to multiply both sides by, well, we need a y, and we need a 5, and we need a y plus 2. Let's do that. 5 first, then the y, then a y plus 2. But y plus 2, we see twice, but we only need one copy, because they're in different fractions. We need a y, and we need a 5. Do that on the left side also. 5y times y plus 2 here. This we need to distribute across that addition on that left side. So we'll have 5y times y plus 2 times 1 over y plus 2 plus that 5y times y plus 2 distributes to the second fraction. We can go times 2 over y times y plus 2 equals, on the right side, there's no distribution, so we can just cancel right away. Just the 5's cancel, though. And we will be left with y times y plus 2 on the right. All right, let's move on down here. Our first term on the left side, 5y times y plus 2 times 1 over y plus 2. The y plus 2's cancel, and we will be left with 5y in that term. The second term, 5y times y plus 2 times 2 over y times y plus 2. Here the y's cancel and the y plus 2's cancel, leaving us with the 5 times 2. Bring down the equal sign. We can distribute the y on the right side. We'll get y squared plus 2y. And what I notice, the bells go off in my head, that see a y to the first and a y squared, so that tells me bring everything to one side so that we have a 0 on the other side. So I'll subtract 5y and subtract 10 off the left side. 5 times 2 is 10. And we will get 0 equals y squared minus 3y minus 10. All right, we'll go ahead and factor that right side. 0 equals y minus 5 times y plus 2. We had y squared minus 3y minus 10. We needed the negative 10 to factor. We have 1 and 10 as an option, or 2 and 5, and we need these two numbers to add to a negative 3. So a positive 2 and a minus 5 equals to negative 3. So from this we get y minus 5 equals 0, or y plus 2 equals 0. Add the 5 in the first one, we get y equals 5. Subtract the 2 in the second one, we get y equals negative 2. We'll go ahead and double check in the original. whether these are going to work. We had a y plus 2 in one of them, so I'll go to a different color here. Let's go green, Christmas. Here, y cannot equal negative 2, and then y cannot equal 0. And those are our restrictions. We did get a minus 2 there, so that one's actually not going to work. But the y equals 5 will work just fine. There's no reason that that wouldn't work. So we can conclude with the solution set is the set containing just the number 5 here. All right. Just one more to go in this section here. Let's go ahead and move to the top right. Part D, where we have minus 3 plus 8r over r plus equals negative 4 over 7. On the left side, negative 6 over r minus 3, nothing factors there, plus 8r over r plus 9. Again, nothing factors, so we'll just bring these down. Minus 6 over r minus 3 plus 8r over r plus 9 equals. On the right side, we have negative 4 on top, nothing to do there. But the bottom, r squared plus 6r minus 27. Looks like we can probably factor this. Let's put an r in the first positions of our factors. And then 27, we could do 9 and 3. We want a minus 3 and a plus 9 to multiply to be negative 27 and add to be positive 6. So that's nice. The r minus 3 is repeated. The r plus 9 is repeated there. So our common denominator that we multiply both sides by is going to be r minus 3 times r plus 9. Great. So on the left side, we'll distribute the r minus 3, r plus 9 to the two terms, the negative 6 over r minus 3, and then again we'll distribute it to the 8r over r plus 9. Let's write that out now. So we've got, we need to move things over, r minus 3 times r plus 9 times, I'm going to put that minus on top. That's minus 6 over r minus 3. Just move that negative to the top. It's totally fine there. And then plus r minus 3 times r plus 9 times 8r over r plus 9 equals, on the right side we can cancel right away. The r minus 3's cancel and the r's plus 9's cancel, and we're left with just a minus 4 there. All right, on the left side, border here. On the left side, we have r minus 3 times r plus 9, and we're going to multiply this by the first term, negative 6 over r minus 3. The r minus 3's can cancel, and we will be left with r plus 9 times negative 6. Put that negative 6 in parentheses, so we're really emphasizing that that's multiplication, not subtraction. Don't want to have any confusion there. And then plus the second term, we had r minus 3 times r plus 9 times 8r over r plus 9. The r plus 9's can cancel, and we will be left with the r minus 3 times 8r, and then we'll have this equal negative 4. All right, on the left side now, we have r plus 9 times negative 6. We'll distribute the negative 6 across to get negative 6r minus 54. And then plus the 8r can distribute across the r minus 3 to get 8r squared minus 54r. And then bring down the equals negative 4. Once again, I see a squared term and a first degree term. So this tells me that I've got a quadratic, so I want to bring everything to one side. Let's do that in the next step. Let's combine like terms first. We've got 8r squared. Put that squared term first. We'll have minus 51r, the minus 6r, and the minus 45r. We'll have a minus 54 equals negative 4. If you did both of these steps in the same move, that's totally fine. I'll add the 4 to both sides, leaving myself with 8r squared minus 51r minus 50 equals 0. This looks a little daunting here. We've got an 8r squared minus 51r minus 50 that we need to factor. And let's see, do I want to do the AC method or the guess and check? I feel like I want to do the AC method here. I'm going to do 8 times negative 50. That's going to be negative 400. And I want to look for a positive and negative number that add to negative 51, or two numbers that subtract to 51. So 400 factors as 1 and 400, 2 and 200. Still a ways away here with the differences. 3 does not go in, 4 and 100, getting closer. 5 does go in. 5 goes into 100 20 times. 20 times 5 is 100. So 400 would give us 5 and 80. 5 times 80 is 400. 6 does not go in. 7 does not go in. 8 should go in. 8 goes in 50 times. Definitely getting closer there, but that's a 42. Ooh, I think we don't have any factorization possible here. 9 doesn't work. 10 and 40, difference of 30. See, the differences are getting smaller as we go, so we skipped that difference of 51. I could finish filling out this table, but at this point I'm going to just recognize that this doesn't factor, so we have to resort to the quadratic formula. So that doesn't go away just because we're in a different section. I'm now going to say that r equals negative b is going to be a positive 51 plus or minus the square root of negative 51 squared minus 4 times 8 times negative 50, 4 minus 4ac, all over 2 times 8. And let's work through this slowly. We've got 51 plus or minus the square root of negative 51 squared. I'm not even going to attempt that by hand. 51 times 51 is 2,601. We'll go plus, because there's two negatives there, the minus 4 and the minus 50. 4 times 50 is 200, times 8 is 1,600. And this is all over 16. Go equals 51 over, make sure that fraction bar doesn't start dropping that 51 off, plus or minus the square root of 5,201 over 16. So r equals 51 plus the square root of 5,201 over 16, or r equals 51 minus the square root of 5,201 over 16. Well, I'm going to plug that into the calculator here. In fact, let's go ahead and graphic calculator out. Let's see if we can just get a scientific. I don't need that anymore. Scientific calculator. We want fraction bar 51 plus the square root of 5,201 over 16. And then we want the same thing, 51 minus, oops, fraction first, 51 minus the square root of 5,201 over 16, negative 1.3198. Let's see if I can keep these. So we have approximately 7.69 and approximately negative 1.32. Let's go ahead and put that calculator away and get our conclusion. The solution set is the set of r values such that r is approximately 7.69 or negative 1.32. I didn't take the time to check those in the original. Let's make sure I'm not messing anything up. The denominators told us up here that r cannot equal 3 or negative 9, and that's not the numbers that we're getting here. So it looks good. These are odd enough that I'm just going to be double checking my work real quick just to ensure I didn't make any mistakes. Minus 6 over r minus 3 plus 8r over r plus 9. I'm looking for typos, and as I look for typos, I'll also be looking for any arithmetic errors. And so it looks good so far on the second line. Cancel those. Negative 4 on the right. The r minus 3, r plus 9. That didn't change a sign. Negative 6, r minus 3 times 8r. That's 8r squared. Minus right there. That number's wrong. So if you caught that earlier, I had a little dyslexic moment right there. So this happens. I'm sure you guys have had this happen in your work. We're just going to go ahead and get rid of this. Get rid of this. That would have been right if I wouldn't have made that mistake. But hopefully this problem actually works out a little bit nicer. 8 times 3 is definitely not 45. That is 24r equals negative 4. All right, so I'm going to have 8r squared. All right, combine my like terms again. Minus 30r minus 54 equals negative 4. Add the 4 to both sides. And I'll have 8r squared minus 30r minus 50 equals 0. Now we can factor out a 2. The least here, 4r squared minus 15r minus 25. This looks nicer, equals 0. And then this I'm going to do with the guess and check method. I'm going to try a 2r and a 2r, and then with the 25, I'm going to start with a 5 and a 5 and see if that works. If I do a plus and a minus here, oh, the middle terms would cancel, so that's not going to work. Let's try a 4r and a 1r here. That would give me negative 20, negative 20r, and then a plus 5r. And that does give us a negative 15 in the middle like we want, so that works. And so 2 times 4r plus 5 times r minus 5 equals 0. One of them has to be 0. It's not the 2. The 4r plus 5 could equal 0, or the r minus 5 could equal 0. So we get r equals negative 5/4, or r equals 5. Double checking, that was not one of the numbers that r could not be in the original equation. Now we can conclude with the solution set is the set with both of these numbers, negative 5/4 and 5 in it. All right, sorry for that error there, and if you had to erase, I know that's not fun. That was not my intention, although we can see that even if those don't factor, we could still solve it with the quadratic equation. We should also be double checking our work and seeing if we're making any errors along the way. You know, looking for typos and easy to spot arithmetic mistakes are generally the two things that we do when checking our work or going back through it. All right, that's it for this video. Thank you so much, and we will see you soon. Take care now.